Okay, everybody, here we are booting up good old TIS-100 again. So, I've managed to solve the next puzzles. Here are the solutions. We're going to go through, I think we got up to number 12, so let's check this one out. Now, this puzzle is slightly trickier because our task is to read a sequence, read a bunch of numbers, store the smallest value of the bunch and send it out through I, store the largest value and send it out through A. So that's our task. Alright, now, first observation, these are all two-digit numbers, so any of these numbers will be smaller than 100. That's why I put 100 here. Let's go through the logic. Once again, I did it on paper first, so that I could really think through the logic of the program before I did it, because otherwise it's quite tricky. So here we go. I'll step you through what's happening in the process. Okay, so the first one is just to put a large number so that when number 14 comes in, it's definitely going to be the current smallest number. Yeah, so here's what we do. First of all, this first one, it splits the number into 4 and it sends it 4 times. So the number 14 gets sent twice down this way, twice this way. One restriction of this assembly language is we need one number to compare, and if it's a good one, we need to record it. Okay, so you actually need 2 copies of each number through each channel. 2 to work out the minimum, so 1 to actually do the subtraction to work out if it's smaller or if it's larger, but then you've got to send a copy of the same number through in case it is the smaller one and you need to keep track of it. You need to save it. So that's why at the top I'm sending a number twice this way to work out the minimum, twice this way to work out the maximum. Both of these boxes use a similar logic, so here we go. Alright, we start, in fact I'll just run you through it. Okay, so the first number is 14. I've already preset a number to 100 so that it's going to find the minimum. It's not just going to find a 0 and recall 0. That's a bug that I had earlier. So now I subtract it. 100 minus 14 is 86. Now, if I had already stored a large number and I subtracted it, then the smaller number would yield a positive result. So here we go. I want to keep the number 14 because it's smaller than 100. So we hop down to keep. Okay, so now we bring the copy down. Remember we clone the number 14, one to check if it's larger or smaller, the other one because we want to keep it. So now number 14 gets stored here. That's the number we want to keep. And after we keep it, we've just got to check if it's a 0, because if it's a 0, we don't want to keep that as a minimum number. We want to send. Yeah, so this it checks if the number is 0. If it's not 0, then that's fine. Now we save it into the backup. We go back to the start. So now the current minimum number is, smallest number is 14. I'll just step you through the next bit quickly. Number 73 went into the system. We subtracted it. It's a negative value. That means 73 is larger than 14. We don't want that value, and so we just keep 14, go back to the start. The 14 is still in the storage. We haven't stored the larger one because 14 is still the minimum. All right, so there we go. Now, 58 comes through. Don't want that. All right, now have a look at what happens when 0 comes through, because 0 is a smaller number than 14. So we've got to make sure we don't store this number, but send the output because it's the end of the sequence. So subtract. We've subtracted it. It's a positive number. Okay, 14 minus 0 is 14. So it's a small number. Now, do we keep it? We've got to check. The number that the backup we sent through is 0. And so, if it's equal to 0, we actually want to send the number. We don't want to store it anymore. We want to send it. So then we go down to send. We swap out the backed up number, which is 14, the minimum of the first bunch. Send it down. So 14 is sent through. We go back to the top. We chuck 100 back, and we start the next sequence. Okay, and then we step our way through. Now let's go through what's happening on the maximum side, because things are slightly different here. There are slightly different problems we've got to solve here. I'll just step you through to a 0, to a new sequence now. All right, here's the start of a new sequence. Number 50 gets chucked in here. So, what are we doing? We're subtracting 0, which is the starting number, from 50. Of course, it's a negative number, so we actually want to keep this because it's the current largest number. We keep, we save it. So number 50 is saved because it's in this group. 50 is the current largest number. Let's check 71 now. Okay, so 71 gets thrown in here. Once again, 71 is a larger number, so we keep it. Okay, so we keep it. It's over here. Next number we throw in is 60. 60 gets chucked in. Now, 71 minus 60 is 11, and so it's not the maximum number. So we don't want to keep it. We skip through there. We move the next number in because we want to check if the next number is a 0. Okay, so we move the next number in. It's a 60. Doesn't matter. We don't need it, so we go back to the start. Now, let's see what happens when 0 comes through. 0 comes through. We subtract it. You've still got the same number. So now we check if the number is 0. The number is 0, so we go down to the send. We swap out the stored number, which is the maximum, and we send it down. Okay, then that's how we get this program working. Here it is, working its way through, and there it is done. Now, the solution was pretty good. Average number of cycles, good number of nodes. We didn't have to use a whole lot of space, and we used not very many instructions as well. So there's a solution to number 12.